then we have a circle with center A passing through B, and the circle with center C passing through D. That's kind of weird. Let's see, if I do that, let me make AB short and CD longer. So these two circles. Then we see, where does BD intersect the smaller circle again? And so we let that be P. It almost looks like P lies on AC, but it doesn't. We could make it. I think that's fine for now. And draw the circle with diameter PD. And okay, so this is kind of random. Okay, so circle with diameter PD. So it meets that at X, and then it meets the other circle at Y. This is X, and this is Y. And then we draw the this is just so random. Like, I don't know. Here's XBY, and we draw the center. Oh no, we don't draw a center. We draw the circumcircle and we see where it meets gamma 2. So the big circle meets it at Q, and we want to show that BD and Q are collinear. Okay, so let's see. I wonder if it's easier to let BD meet the circle at Q and then show that that's cyclic. It's probably an easier way to do that. So we could let Q prime be the intersection of this with that circle. And then we want to show XBY Q prime is cyclic. We need to use that this is a diameter, so angle PXD is 90 and PYD is 90. So maybe it's worth drawing those in. Okay. Okay, so how would we show that cyclic? Angle chase, power of a point. Yeah, let's think what the best way is. Let's see. So I feel like there's some point we need to add to this figure.
Your diagram is not correct.
Why not?
Just because the problem says that A, B, C, D are clockwise in this order. But I think it doesn't really make a difference.
Interesting. Should I redo it so that it's clockwise? Let's see. It's kind of
I think it wouldn't be hard.
Yeah, so basically it's saying that like
you just have to switch C and D, kind of.
Yeah. And then let's see. Okay. So we have A, B, C, D. Passing through D, then BD intersects P. So BD intersects a small circle at P and the big circle at Q prime. And then this circle with diameter PB meets the two circles at, okay, so this circle meets them at X and Y. This line meets them at P and Q prime. And then we want to show that X, Y, B, Q prime is cyclic. So that would be like a very flat circle. Maybe I can make that circle look a little better. Maybe something more like that. It's kind of a big circle, but I guess that's okay. How do we show, like, do we want to do power of a point from, I don't know if we want to let X, Y intersect beat that and then try to, oh, if these are concurrent, then that probably makes the problem easy. So we probably first have to show these are concurrent. And then it's probably power of a point, is what I would guess. So let's think about that. Okay. So how do we show x, y, and f are collinear? Could we show like FP, like he's power of a point somehow, or so yeah, we want to show that these are collinear. That itself is kind of an interesting fact that those are collinear.
Yeah, I solved the problem. You don't need to do anything really
Oh, really?
special. You can just angle trace.
Okay.
So it will be a little hard to explain my solution since our diagrams are still quite different,
Okay.
but I will try.
Did you call this Q prime, or did you make it like the original definition of Q?
Q prime just intersected and then procyclic. Yeah, that's just better.
Okay.
Okay. I intersected DC with the big circle
Okay.
and also PA with the small one.
Okay.
PA.
So, and it looks like
I think that's a coincidence.
okay, you don't even need that they concur.
No, I think that is not true in general.
Oh, it's not. Okay. Let's see. Yeah, you're right.
Okay. So I drew in those two because then we would get obvious collinearities because of the 90-degree angles. So that would be DXH and YPG.
YPG and DXH.
Yes. That makes sense.
Yes.
Okay, now I looked at the angle XBQ prime.
Mm-hmm.
That angle is 180 minus XBP,
Mm-hmm.
which is half of angle XAP.
Okay.
Actually, you can just leave it at let's just say it is XHA for now.
Okay.
So we would want to show that XYQ prime is equal to XHA then.
Yes.
XYQ prime is something we can calculate, I think, because XYQ prime is DYQ prime minus DYX.
DYQ prime minus DYX.
Yeah. DYX is XPB, So that's okay. And the dyq prime is
It's going to be 90 plus q prime y g. Well,
actually, we have 90-degree angles. I forgot.
yeah.
Wait, so dyp is 90. Yeah. So I cannot figure out the angle trace now because it is different.
No, okay. I think I got it. Let me just write it down on paper, and then I'll tape it up. So
Okay.
basically, you want to show angle XBP is q prime YX. So we're gonna write it down. XBP equals YX, and XBP is XHP. And q prime YX is q prime YG minus XYP. And that would be PDG minus XDP. Okay. So I wonder, let me see, I did a little angle chase. I think it's like we want to show that this equals this. Yes. And let's think about that.
You can prove that triangles APB and CDQ prime are similar.
APB and CDQ prime. Okay.
They're actually homothetic.
CDQ prime. Okay. So I think that is like the key. That's true. So they're both isosceles. How do you know that they're similar?
Because you have CDs parallel to AB, you get one other angle.
Okay. So I think I've solved this. All right. Yes. Okay. So PDG minus XDP is APB XDP, which is XHP, which is XBP. Okay. So, all right, I got it. So first we're going to show APB and CDQ are similar. So, prime, since both are isosceles, and angle ABP is BDC. That's where we use the parallel. Okay. So then I will do an angle chase. So I'll write out the definitions of the points in the end, but we have angle q prime yx equals angle q. Why not just do them all separate lines? Q prime yg xyp is equal to angle xdp is equal to angle APB minus angle xdp angle. See how that looks. Put it all in one line, so let's see if we could split it on two separate lines. See how it turns out. Let's see what this, there we go. So that implies that q prime, so we have q prime yx is xbp, so q prime yxb is cyclic. Q prime equals q. And that means that B, D, and Q are collinear. B, D, Q are linear. Okay, so, and now I'll write the definition now. So let B, D, let G and H be the antipodes of D and P. Then let BD meet gamma 2 at Q prime. All right. Let's see if I can find a problem that involves, I guess the best problems involve like an orthocenter and an in-center, or like an circumcenter and in-center. Let's see if I can find one like that. So let me just check this quick. So APB is similar to CDQ prime. And then we have this angle chase. Q prime YX is Q prime YG minus XYP. And Q prime YG is PDG, because those both intersect the same arc, and XYP is XDP, and then PDG is APB. So because those are similar, and then okay, so APB minus XDP would be XHP, which is XBP. Yeah, so it works out eventually. But yeah, it's kind of just like a bash, not the most elegant. This, let's see this one. So this is X centers. We have two X centers. This looks like it might kind of be interesting. But okay, so this is 2013. What is the control of? Function F11. Okay, so we have a triangle ABC, and we draw the X centers opposite B and C. Oh, I can use my tool. Whoops. So BAC and but yeah, it gets messed up because of, yeah, I probably need to redo the tool. Because sometimes tangent lines like don't show. So we have B1 and C1. And we see, where does it meet the circumcircle ABC? So it's going to meet it at the midpoint of arc EAC, right? We call that, like, what do they call it? They call it E? No, they call it D. So D is the midpoint of arc BAC. Is there even any point? Yeah, they do use the X centers later. Okay, so B1E is perpendicular to CA. So they're saying this is E. Oh no, it's not. It's basically where these two intersect, which is kind of interesting. So they're saying you intersect these two at a point E. And then you draw the circumcircle of ADE. This is weird. So we have ADE. And it's gonna pass through F and J because it's all right angles. Is it that obvious that it's gonna pass through D? I don't know if that's that obvious, but maybe it's like a 9-point circle or something.
It is obvious by spiral similarity, I guess.
By
Because
spiral similarity. Okay.
do you know if JEF exists?
Do we know if what exists?
Oh yeah, okay. Yeah, this part. Okay.
Yeah. Okay. So then we draw the tangent at D. But to which circle? The tangent to omega. What? Okay, so it's the tangent to the smaller one at D. And it meets AE at F. This is very random. So this is F. And then G and H are on AE. So that DGH is perpendicular to AE. Okay. So they're on, so this is G. And this is H. It seems awfully complicated. And we draw the circumcircle of HGF. And it meets, this is so weird, at I and J. I might even have a tool for the foot of the altitude. So we have D to AH. What the heck? This problem is just crazy.
I think it is just fake crazy.
It's
It
fake.
is much easier than it looks.
Probably. J is this point. And we want to show that AI passes through the midpoint of DJ. So that doesn't look right from this. So let's see, maybe I drew something wrong. So let's see. So B1 and C1 are the excenters. They meet the circumcircle at D. And then we define E. So B1E is perpendicular to CA, C1E is perpendicular to AB. We draw the circumcircle of ADE. We draw the tangent to it at D, and it meets AE at F, and then G and H are on. Wait, G and H are on AE. Oh, I didn't draw H right. Okay. So I need to. Wait, DGH is perpendicular to AE. But yeah, this. Wait, G is on AE, and H is supposed to be on Omega. Oh, H shouldn't be on the big circle. It should be on the smaller circle. That's what I did wrong. So this should be H. And then we draw the circumcircle HGF. And it meets that circle at a point I. So that's I. And then J. Let's use this. D to AH. D to AH. What do you call it? Fake hard? It's like fake hard.
What I saw right now is that you actually don't need excenters, A, B, C, and all that stuff to even define the problem.
Okay.
So it is just like stated really poorly.
Okay, so D is just the midpoint of our BAC. Do we need B1 and C1?
It is the midpoint of B1, C1.
We don't need them.
Kind of. It is important to add in the third excenter just to
Okay.
understand the problem.
Okay. So, 1 sec. Let me do it right now. Dang it.
You could have just intersected C1, B1, C1B, and B1C.
That's true. All right. So yeah, this is very messy. So let me clean up the diagram just a little bit.
Yeah. Firstly, hide the circles. You don't need them at all.
Okay. Let's see. So what did I do here?
The top one is also not needed. The bottom one.
This one.
Yeah.
Whoops. We just want to see where the center of it is, basically.
Yeah.
M.
So we can obviously pick our main triangle to be C1M B1.
Here.
And everything is more natural with that. So
That's
E.
the in center. Yeah.
Yeah, E is just the circumcenter.
Okay.
Uh,
So okay, the circumcenter.
yeah. D is midpoint of B1, C1. A is the foot of altitude from A. And okay, So how could we state this problem? We have a right triangle. We have a right triangle ADE, and we have its circumcircle. You can zoom in the picture to see better.
Okay.
So we have this right triangle ADE. We have its circumcircle. Point G is just the foot of altitude from D to AE, and H is the intersection with the circle. Point F is the intersection of tangent from D to the circle with AE. That is how we would define F.
Hold on one second. Do you mind if I make the diagram look a little nicer for a second?
Yeah.
Okay. Yeah, it's because I used the X center tool. I basically drew in too many points. So J. Let's see. So this is just AH. And I forget what. I don't think I need that. That was just for the. I guess that's the downside to using the tool to draw it. Whoops. So. And then. Okay, so let's call this A1. All right, so we could just say it's A1. Okay, so the circumcenter. What is O?
Okay, this is much nicer.
Yeah, I don't even know what O is anymore. But let's see. So we have the circumcircle ADE. So
yeah, E is the circumcenter of A1, B1, C1. So it's just important that ADE is 90 degrees.
So yeah, so ADE is 90 degrees. So one sec. So E is the circumcenter of A1, B1, C1 because just trying to think.
ABC is the orthic triangle, and when you take an altitude like that, like B1, F1, then that would make a isogonal line to the other altitude.
Okay, because
C1B.
C1C and C1E are isogonal and the same the other way.
Yeah.
Okay.
And now you can define the whole problem just by points A, D, and E themselves.
A, D, and E?
Yeah. It would go like this. You have that triangle ADE, which has right angle at D. Then you would define G and H as the intersection of perpendicular line from D to AE, with those two, AE and the circle.
So H is really just a reflection of D over AE, right?
Yeah.
Okay.
J is altitude from D to AH. F is the point intersection of tangent from D, and
So I could just hide a whole bunch of stuff.
you need that circle for point I. Yeah, you basically don't need half of the diagram, just because you can define everything by just 3 points.
Okay, so I accidentally got rid of a circle. So that's funny. You're like, yeah, I think it's fake hard. It definitely is fake hard.
Yeah,
It's
and
like
it is just really, really stupidly stated.
it's ridiculous. Yeah. It's funny.
The worst thing is that you don't even need B and C.
Yeah.
And that circle also.
That's funny. I just threw random stuff just to make it look harder. Okay, so we have AD is a diameter, D is just any point on that circle, and H is
Hide also J1.
J1.
Yeah.
So we have like
now
this
we can
height.
actually state the problem. AE is diameter, D and H are reflections in AE, J is the obvious intersection, and DF is tangent. And the only kind of hard point is I, which is intersection of these two circles.
Yeah.
And we want to show that DJ bisects AI.
Or AI bisects DJ.
Yeah.
Okay. I wonder if we could project so we JIB infinity onto the circle. So that would be HD I. So I think it's the same as saying that HDI M is harmonic, which I think is the same as saying DI equals DM. Let me think about that. Maybe not. I wonder if Fi and M are collinear. It looks like it. So yeah, if we could show Fi and M are collinear, then we could probably because we know FD and FH are both tangents. So it's the Same as saying that Fi and M are collinear, because that would show that that's harmonic. And is that obvious? So I wonder if FH, let's see, we want to show Fi and M are collinear. It seems like it should be an angle chase. Because since angle HAM is 90, HIM is 90. So we just need to show angle HIF is 90. Basically, we need to show, I think these, yeah.
No, this is just trivial. I solved it. You just need to observe that you have those 90-degree angles. So JD is perpendicular to AH.
Mhm.
That means HAM is 90.
Yes,
So HIM is 90.
yes.
And FIH is also 90.
Why is FIH 90?
Because FIH is FGH.
Is FGH? Yeah. And so then that proves that, yeah, that solves it because it shows that HIDM is harmonic, and then we project through A onto JD, and then that solves it.
Yeah.
This is the most dumb problem ever. Okay. Should I write up the solution from the start, or
I think it's better we move on.
yeah. Let's see. Okay, how much time do we have left? Let's see if we can find if any of these problems are better.
Do you have anything which isn't from Korea?
No, I took all the problems from there. This one might be interesting. Let's see.
It's an isosceles triangle, doesn't look very appealing.
Maybe this one will be better. This has like an in-center and a circumcenter. Let's see. So we have a triangle with in-center I. So yeah, I guess the best problems involve like an in-center and something else, or an x-center. Oh, I don't think let's see. I'll just do encircle tangencies. Oh, AI actually does mean a circle, so then I should use this one. It's weird. I don't know why I can show the circle, but that is the midpoint. So this is M. And AD and AC at D and E. And then O is the circumcenter of BDE. Does it lie on A? Yeah, because it has to lie on the perpendicular bisector of BE. So we call that O. L is the intersection of the altitude from A to BC. So that's L. A and L lie on the same side. Wait. L be the intersection of. Oh, it's the intersection of the end circle. Okay, so I'm gonna call this L. Then we have a circle centered at O passing through L. And AL meets the circle again at N. So this is like N. And then we want to show that LD and MB meet on the circumcircle of LNE. So we want to show LNE in this point is cyclic. So these look perpendicular. Let's think about that. So LDH and all right. The circles almost look concentric. I don't think they are concentric. Maybe they are. So what are these circles? We have I forgot what this circle is right here. Good. So this is BDE. And this, what is this circle? I don't think I need that, right? Oh, a circle centered at O and passing through L. And then AL, oh, AL meets that circle at N. So I did the wrong circle. So really, I think that's just a way of maybe trying to get a right angle or something. So this should be N. And we want to show HNLE is cyclic. Yes. So yeah, these circles are going to be concentric because they're both centered at O. They're always so close together. That's the thing. I think if you make it a tall triangle like that, then maybe, yeah, the circles aren't so close together. But I'll shrink it just a little bit. Okay. So we want to show HNLE is cyclic. Just going to move it. I think that looks. It's hard to get a perfect diagram, but I think that's okay. Yeah, so point N is just weird. I almost feel like it's confusing to see the circle. Like I'd rather just think that like ONL is isosceles because that's kind of the point of it. So ONL is isosceles. So yeah, I mean we could just say reflect L over BC. Well, it's not the reflection of L over BC. LD and MB. So yeah, it's like asymmetric. We could do the same thing on the other side of the diagram. So first of all, is it clear? Is this angle right? Whoops. No. So I thought it was, but it's not. Let's see if we can use power with points somehow. So where does LN and HE intersect? Maybe if I could show this point is collinear with something else, then that would help us use power with point. don't think it is. Okay. Yeah, that last problem is ridiculous. Yeah, I thought Korea might be a good contest because they usually are one of the top people at IMO or have been recently, but yeah, that was just a bad problem.
This problem looks terrible.
Why?
I don't know. It is really ugly.
It just looks bad. Do you want to keep
Yeah.
solving it or
I would prefer something else.
okay?
But I think any of those Korea problems would be kind of the same.
Same idea, or it's just messy. Do you want to do ELMO?
Yeah, we can do it. We can do those. ELMO usually has interesting problems.
Yeah, the only thing is I think I've probably done all of them before, but maybe I don't remember all of them. Let's see.
Let's do like G13. Yeah. G14. That's an if and only if. That doesn't look interesting.
Yeah, I don't like if and only ifs. Yeah, I agree. This one I've done before. I don't know if I remember it, but
I think I've done the G1.
The G1.
Yeah.
Oh, this one I've done before. This one's actually pretty easy. All it is like
Well, it's a G1, so makes sense.
yeah. I think I solved it in like 2 minutes. It's just a spiral similarity. That's it. Let's see. This one has a bunch of 9-point circles. So on BH and CH. That one seems it's like a fixed point problem.
Let's do like some medium problem from ELMO.
Okay.
Like medium difficulty.
Maybe this one, or is this too easy? Let's see. Well, 3 is, yeah, if it goes all the way up to 10, then 3 is going to be kind of easy. Maybe this. Too many mixed linears. The radical center of the 3 mixed linear ring circles.
I think that one's kind of well known. You just need to prove that the radical center of the mixed linears in circles are collinear with OI. And that's
really?
like some commodity or something like that.
Interesting.
Maybe the G6.
Okay, this one looks okay. Great. Don't look at the solution. So we have a cyclic quadrilateral. All right, let me delete the diagram here and problem in. Forgot what year it is. I'm just going to write LMO. And then we draw the circumcircles of AOB and COD, and they meet at G. Just random. And then AOD and BOC. Okay, so this is G. And it's H. So then we draw the circle passing through G and the feet of the perpendiculars from G to A, B, and CD. Oh, that's interesting. Let me use this. And then this. I don't want those to be so squished together. Okay. So we have this circle and this circle. And we want to show the midpoint of GH lies on the radical axis of those circles. It's kind of random. We call it M. So another way to say that is if we extended GH, it would cut these circles at equal distances. It's another way to say it. So this equal this. I guess I might as well draw on those points. I don't know if that's the solution, but so yeah, I wonder what happens if we invert about the circle ABCD centered at O. So ABCD are all fixed. Basically, this circle goes to the line AB, right? And then this circle goes to the line CD. So we probably want to draw those points, right? I just don't know how the radical axis condition, like what it turns into after inversion. That's the only thing. So inversion would do a lot to the diagram, right? But yeah, what is it? I don't know what inversion does to like powers of a point of the circle, respective circle. That's the only thing. But I mean, ultimately, we want to show that GL equals HK, and maybe we can use the inversion distance formula to help with that.
I think inversion is unnecessary. The only important thing is to complete the quadrilateral.
Okay.
Then the problem just becomes then you can convert the problem to just one triangle and its orthocenter.
Oh, really?
So basically half of the diagram also is gone after that.
I didn't think ELMO was like that, but I guess so.
Maybe we picked the wrong problem.
So let's see. So, okay, so so how does it convert to a simpler problem?
So firstly, it is obvious that P and N lie on those two circles because of the 90-degree angles.
Yeah.
Then let's say by inversion, you can prove that O, G, and P are collinear.
Okay.
That would basically mean that that inversion takes G to P and H to N. And it is like well known that like let's say by Ricard or something like that, that pH and Gn are altitudes of triangle PON.
PON. So actually, it's obvious by the radical axis theorem that OG and P are collinear and OH and N are collinear.
Yeah.
So, and then by Pard's theorem on OPN, yeah, because like,
It's kind of well known.
yeah. Okay.
And then we don't need quadrilateral ABCD. We just have triangle OPN and its two altitudes. And then we want to show that M lies on the radical axis of circles with diameter HN and GP.
Okay. So really, we can hide like a whole bunch of these circles, right?
We can hide most of the diagram.
Okay. So basically, you have triangle PON, and G and H are the feet of the altitudes. So we can hide ABC. Can we hide all those?
Yeah.
Okay, we just want to show the midpoint of GH lies on the radical axis of those two circles we drew. So
Yeah, and also it is obvious that O lies on the radical axis just by power of a point.
okay.
So it would be enough to show OM is perpendicular to the line passing through the centers of those two circles.
Okay.
And we know what those two centers are.
Okay, hold on just a second. So how do we define these circles? So we draw the perpendiculars from G. Okay, so you start with PON, and then what are, so this was one of the circles, and this was the other circle, right?
Those two circles are just the circles with diameters HN and GP.
HN and GP. Okay.
That's why we don't need basically anything anymore.
So all we really need is yeah, we really don't need anything. Like, so you're saying we just start with triangle PON, and then G and H are the feet of the altitudes, and M is the midpoint of GH, and then we draw the circles with diameters P, G, and HN, and we show M has the same power with respect to them.
Yeah.
We know O has the same power by power of point. So that means we want to show OM is the radical axis.
So my idea is to draw in the midpoints of HN and GP And then because those two are the centers of these two circles, you'll just need to show that OM is perpendicular to QR.
Okay. And that's obvious because PGHN is cyclic, so OM is
Is it obvious?
maybe it's actually maybe not. Is it? I thought it might be, but yeah.
Yeah, not obvious, but not hard. It can't be hard.
Yeah. Let's see if we can find the most elegant way to prove that. So OM is perpendicular to QR. So MQ is parallel to HP and MR is parallel to NG.
Then M is just the orthocenter of OQR.
OQR. Oh. And so, yeah, that solves it. Yeah.
That's probably the most elegant way.
I think so. Yeah. Nice. So, yeah, I did not think ELMO questions were this easy, but maybe they are.
Well, that's because we didn't pick G14.
Yeah. Where was I looking at? So, oh, I was looking at them here. Geez, okay, that's got two mixed linears. This one looks like it, but yeah, you're drawing all three mixed linears. That's the only thing, so it's a little messy. This one's kind of interesting. So you have the 3 feet of the altitudes, and you draw the circumcenter of that triangle, and D, E, and F.
D, E, and F are not the perpendiculars.
Oh, they're not the feet of the perpendiculars. Yeah. You have like 2 orthologic triangles, right? That kind of what it is?
Not sure. I forgot the definition of those stuff.
Orthologic. This one looks short, but it has a 2 in it, right? A 2 is inelegant. Although there's no 2 before that. Oh, but it's isosceles. Yeah. We don't want isosceles triangles. What about this is kind of it's probably just Pascal, right? Yeah.
Yeah.
Looks like Pascal bash. Let me go back further. I thought I just saw this one. Maybe it's like a different BH equals 2HC.
It looks exactly the same.
This one looks kind of interesting. Maybe this one. I like this one because it has medians. I'm gonna go with this one.
Let's do it.
For what?
Let's do it.
All right. Don't look at the solution. Don't look. All right. Yeah, we started a couple minutes late, so we could work on it for like 5 extra minutes maybe. If you want. It's got a 9-point center and medians. That sounds like a good combination. So there we go. And I have a tool for the 9-point circle. That should help. Okay. So we draw the 2 medians from B and C. And it intersects the circle at D and E. So let's rename this Q, and now we can do D and E. And let N be the 9-point center, because we're going to want it for later. Through D tangent to AC at C. So we want to circle through D tangent to AC at C. So do we draw the perpendicular? I think we draw the perpendicular. I think we do it like this. So the perpendicular bisector VC, and we see where it meets this, right? And that will be the center of it. So we have this circle. And then we can do the same thing on this side. Through tangent to AB. No, we want it tangent perpendicular to AB. Like this. So we have this circle. And oh, I think I remember this problem. I forgot the solution though. Do you remember this problem?
No.
I think on AOPS I posted a solution, but I forgot what it was. So we want to show O1. I think N is the midpoint of O1, O2, and there's some parallelogram. I don't remember exactly what it is though.
Well, then we should have parallelogram with O and H.
With O and H.
Circumcenter and orthocenter.
Okay. Oh yeah. That's a good point. I don't think I've ever made an orthocenter this way, but it works. Yeah. It's tangent to AB. Okay, so what did I do? So do you know when the IMO is?
The IMO is gonna be from 2nd to 13th July.
July. Okay.
So it's about in about a month.
That's pretty soon.
Yeah.
so we want to show it's like a parallelogram with H and O. So O1B is perpendicular to AB, and so is CQ. So that gives us some. Sorry, not CQ, but so is the altitude from C. So that gives us some parallel lines to work with. And then this is perpendicular, and so is this. So we have another set of parallel lines. I wonder if this point. Oh, and the centroid lies on OH, right? So this is gonna also call it G. These are all collinear. So yeah, we want to use that parallel if possible. Like maybe we could let O1B intersect O2C. So those would be perpendiculars. They looks like they meet on the circle. Yeah, that's obvious because like the point that makes a parallelogram with BHC lies on the circle. So yeah, I think that should help. And then like obviously these are linear. So yeah, we can add a good amount of stuff to the diagram. Okay. We need to use that O1E equals O1B. I guess that's the same as saying OO1 is perpendicular to EB and OO2. And it almost looks like these concur. Is that maybe? No, that was just a coincidence. But we have EB and CD, and so yeah, we could define O1 and O2 a little differently if we wanted. So we could say PK is parallel to AB and FL is parallel to AE, or sorry, QL is parallel to AE. We know PQ is parallel to BC, so we have a lot of parallels. So I guess we could try to show that O1H is perpendicular to CD. That would basically solve the problem. So we could try to show HC squared minus HD squared is O1C squared minus O1B squared. I'm not sure how well that works, but an idea. We can go over like 3 minutes just as we started late. Let's see.
So I have an idea.
Okay.
So the idea is to intersect the medians, all medians with those two circles.
Okay.
The whole line. So
Oh,
we want 4 intersections.
okay. One, two, three, four.
I believe it can be angle traced that TS is parallel to EB.
Oh, really? Okay.
It looks like.
And
It
then
can be angle traced.
MR is parallel to CB.
Yeah. Also, I proved that MAT are collinear, and also that we have that MT is parallel to BC.
Ah.
Furthermore,
sorry, go ahead.
Furthermore, we have that MACB is a parallelogram, and similar for the other.
Okay.
And the last thing, orthocenter is the circumcenter of MTSR.
MTSR. So
The last one I didn't prove, but it would prove the problem.
because it's the circumcenter, like if we could show MB and TC intersect on that circle, then that would prove it, that H is the circumcenter of it. And it looks like they do. So if we could show those two intersect on that circle, I think it's probably just an angle chase. Yeah. Yes. So because basically the orthocenter is actually the circumcenter of the, what do you call it? The triangle with double the sides.
Oh, yeah.
So
I forgot about that.
yeah. So that would solve it.
So if you could prove that those 5 points lie on a circle, then yeah, since then we would have that HD is equal to HS.
And they do lie on a circle because angle MRB is like MRT.
Yeah, I see it now.
Which is this angle. So yeah.
So basically, we have that H is the center of that circle.
Mm-hmm.
And we want to show that HO2 is perpendicular to EB.
Yes.
But EB is parallel to TS.
Yes.
And
and this is the radical axis of those two circles. It's like TS is the radical axis of this circle and this bigger circle, so HO2 has to
it's
be
easier said that HO2 is the perpendicular bisector of TS.
Yes, exactly.
But yeah. And also just to comment a bit why we have those parallelograms. If you drew in the intersect, let them be like it is, then we would have that QE times QM is QB squared. So, and also that is equal to QA squared. And we then get that BMQ is QBE. Those two angles are the same. And then
BMQ is QBE.
Yeah.
Interesting. I really like. I
QB is
think.
QB.
Oh, what?
QMB is QBE, and that is ACE.
Okay. Yeah, QBE is ACE. So basically that presents a parallelogram.
Yeah.
Interesting.
So what were you saying?
So that's it, right?
Yeah, we solved it. You started to say something.
Oh, no. That was it. But yeah,
Okay.
I can't believe we solved this one that fast. I mean, I kind of knew from before that this was a parallelogram, but still, that was pretty cool.
Yeah.
So I don't think I'm going to type up the solution just because we're out of time, but it was a lot of fun. So yeah, thank you both for hopping on and staying. And for everyone watching on YouTube, thanks for watching. So if you want to join me in the future, feel free to email me at mgreenbeat01. We meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day.